Hope you are doing fine. So today we will be discussing on the data flow of MapReduce. So we won't discuss the architecture of MapReduce in this video. Before doing that, we will understand a high level importance of how or high level introduction to how you would distribute the data and how MapReduce is going to process that internally, and with some diagrams and basic understanding we will have a knowledge on that. So first of all, our requirement, if we want to talk about our requirement, that is requirement is to distribute large amount of file, and this large amount of file is basically distributed over several machines. You can imagine the size is like in petabytes. Now the thing is, this whole collection, the example of this could be like, several web pages and web contents where you have a lot of documents, and you want to search some text out of it. Say for example, you want to search Christmas among this huge amount of large file. So how MapReduce is going to help you and will become very handy over there. So that exactly we will understand. Now before going into the topic, we will have some description on the large amount of data. So you can say like large data amount, and we will be also looking into the how or what is the basic assumption of the processing systems. So the first category, if we talk about large amount of data, so we cannot keep it, because the data is very much large, we cannot keep it in one machine. So definitely the large amount of data is going to be distributed over several machines, and the nature of these machines are simple commodity hardwares or CPUs. And if you talk about those, CPUs and hardwares which comes under the setup of MapReduce, then the configuration could be like you will be having 2 gigahertz of processing power plus 8 kind of GB of RAM, you can say, as a configuration of this commodity CPUs, right? And these commodity CPUs has a tendency, as we know already, to fail. So anytime it can fail, and we need to take proper steps against fault tolerant actions. Okay, fault tolerant measures needs to be taken, and that should be taken care of while we are going to design this type of system, and that we can see in our discussion too. The next thing which is very very important apart from that is, apart from the commodity software's configuration, that is the number of commodity softwares which is taken as a node, number of nodes we can say, that is roughly around, you can say, 1000 node or commodity CPUs can be used here, as in this MapReduce whole setup, right? So if we say we have number of nodes is 1000, then we will see like what type of mechanism or architecture they normally follow. We will understand the simplified version. But before going into that part, we will also have a look on the processing systems topic. So we are not looking for a storage system here. First of all, the basic assumption is we want to read from the already storage system, right? We want to read the data from already storage system, and whatever the output comes of that search result or any type of parsing result of parsing processing, we want to keep that in in some memory. So that is going to be our assumption. Now we will see like how we can go. Okay, now among this thousand of nodes, there will be one node which is going to be treated as a master. Now if we talk about the type or property of the master, master itself is a commodity hardware. So rest of the thousand nodes, which is basically commodity hardwares, the nature of master is alike with that. Now these commodity hardwares is basically, who is not masters, is basically considered as worker, and this worker will have some id from, for example, a to dot 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 n. Now we will also talk about these commodity hardwares which are treated as worker, how they are doing the arrangement, how they are processing it. But before that, we will also look into a matter like the responsibility of master is basically or typically contributing or making a contribution on collaboration. So majorly it collaborates with the worker nodes with some information which he has. Now if we talk about like large file system, as we have already seen in GFS, this large file system has been splitted into some chunks, and these chunks are termed here as a split, and every split could have a size range from, you can say, 2 gigabyte to 2.25, this is 16 MB, 16 MB to 2.256 MB. This is going to be size of which has been prescribed or which has been suggested of a MapReduce algorithm, that it could be a size of split. So if we want to process say for example 1 TB of data, then the number of total size is going to be 1 TB divided by 256, which is roughly around 4000. So 4000 splits would be there, and every split is going to have a memory of 256 MB size. Now the master, what the master is going to have, master is going to keep track and with a table, and this table will have a like split size, split number, and that number is starting from 1 to 4K. Now there would be assigned assigned workers who is assigning which split, and that is going to being mentioned by starting from B, C, D to N. And another is like status, like what is the status of this. It could be like in progress, it could be like completed, it could be like idle. So if anything is idle, that means that is not being assigned yet. So it is, if we see in this architecture, like if we have 4000 splits, and if we have total altogether 1K nodes, which is termed as the worker node, then every worker will have how much of split? That is 4K divided by 1K is equal to 4. That means every split is going to have 4 machines. So that is the basic assumption over here, and every 4 machines is every 4 splits, and if we have assigned in each worker, that means we are making justice from the system design perspective as well, because we are distributing our loads. So it is going to be much better if we have the number of splits in assigned to each worker is always greater than 1, and here in our case it's becoming 4. Now the thing is, if we assume like we have a split like 4, 7, 11 and 100, so it could be like 6, 24, 10, 54. I'm talking about split number B and all these things. So how this thing whole works? So suppose you are looking for a document for an word which lies in this large document called hello, and our worker node is going to find out we are looking for the word in each split. So each split, whenever we are finding it, we try to understand that that split is, I mean, what is the line number where this word actually lies. So if we get that information, we directly go to the worker node. Suppose we got a worker number b, the word, so it directly writes it into his in memory or ram, because writing on in memory or ram is very faster. Then it stores that result into the local disk, and finally when the local disk is having that information, and finally it pushed or flashed that information into the persistent storage. So in this way the search result is getting is actually appearing to the end user. So what happens when your worker fails? For an example, this worker fails. So what is kind of the failure mechanism we are talking about here? So if this worker fails, first of all, how the master knows that? As we already know, like master has a strategy of understanding heartbeat of each worker node. So he sends a ping to every worker node to understand periodically, to understand what is the health of this worker node. When he comes to the decision like yes, this is at least in dead state, then he looks into the table, and from the table he got an information like what is the split number it was responsible for. So those split numbers actually assigned with other commodity hardware. Say for example 624 1054 or 154. 624 10 and 154 is going to be assigned to some other available working commodity workers, right? So now the question is, if it is in completed state, then what is going to happen? It actually checks like whether the completed state means what? Completed state means the search result is completed. That means the result is stored somewhere. So does that storage associated with the local disk? If it is only with the local disk, then that is also gone, because this system is down. But if it is actually returned to persistent storage, then the master doesn't need to take any call. But if it is not associated with any persistent storage but associated with the local disk which is already gone, then he needs to reassign the task and make the status in progress, because he needs to restart that searching process, right? So what if master goes down? Master can also goes down. There are no steps taken care of from the MapReduce point of view, but yes, you can take care of that thing as well. And that is could be like you can take a backup in synchronous manner of master. Backup of master is essential in synchronous manner. That is going to happen perfectly fine. Now the locality, yes, this is a very very important rule which you can discuss with your interviewer. Like whenever the data is coming from the distributed system, locality plays a very important role there. So taking split from the closer location to the work node. Suppose this is our distributed file and it got associated, this file is stored his data into some distributed locations. This is in India, and we are picking this worker node also state is India. So he would like to find out like who is the closest region of the I mean the storage of this split resides in the region, and the worker node is having a region who is closest. So he will always like to find in or believe whenever he is associating any split memory with him or taking any information from the split memory. So he will rely on this fact, like taking split from the closer location is always going to be fun, right? The main objective of worker node is this, because it enhance the overall processing and enhance the and makes the system design makes the system much faster and well responsive. So that is kind of a thing which we want to discuss in this video. Hope you guys will find this video effective. Thank you so much.